So on the count of 3. 1, 2, 3.
I can multiply a polynomial expression.
Awesome. All right, let's talk about the vocabulary there. We have talked a lot about monomials. Not monomials. We did monomials actually a couple weeks ago, right? We're doing in the skills check, we're doing monomials with the exponents, right? One term, right? We've done a lot of binomials with 2 terms, and we've talked about trinomials with 3 terms. What does the prefix poly mean? Does anybody know?
Multiple.
Multiple. It means many, right? So this is a many thing. So we're going to talk about many terms, okay? We have been doing a lot of solving lately, where we're finding solutions and answers, which means we get a number. In today, we're only going to get an expression, which means there's going to be variables left, there's going to be lots of terms left, and that's the way it's supposed to look, okay? All right, I want you to take, I don't know, about 45 seconds and just skim through that, kind of get the gist, okay? Just skim through it really quick. All right, so we have multiplied polynomials before. We've multiplied a binomial times a binomial. We've distributed monomials into other polynomials, okay? We've done that before. We're just going to make it bigger, all right? One thing I did skip over with you guys is I skipped over, there's a whole lesson, because the regular Algebra 2 classes have actually already done this, but they skipped doing quadratics. So they got to go back and do their quadratics. So we're kind of ahead and we're kind of behind, okay? So they were doing division of this stuff today. I saw them on their whiteboards, okay? But we're going to get caught up and stay ahead, okay? We have to get to trig second semester. They don't. So, but the whatchamacallit. So one thing I skipped over was there's a whole lesson on polynomials about combining like terms. I don't think we need to spend a day on that, right? We've been combining like terms since middle school, okay? Just remember your like terms. An x squared has to go with an x squared. An x cubed goes with an x cubed, okay? You can't put an x squared and an x cubed together, all right? That's all you really need to remember about them, okay? All right. We got to perform the following polynomial multiplications. These problems are right out of the textbook. I don't like that they have their highest exponent last. It's not a big deal. We're going to deal with it. But sometimes it happens that way. Sometimes it doesn't. It's okay. I like to have something that's a tool I can use to be able to, to make sure I know I've got every single thing multiplied by every other single thing, because that's what we're really doing. You're multiplying everything in the first one times everything in the second one, okay? So the way I do that is I get out the box. All right. I sometimes have a love-hate relationship with the box, okay? All right. And my box's dimensions are whatever my polynomial's dimensions are. So I've got a binomial times a trinomial. So I drew a 2 by 3 box. I don't have to draw the box that way. I could draw the box this way. And I'm going to get the same outcome. Okay? Your choice on how you draw the box. All right. Across the top, I'm putting the trinomial. So 1 minus 4x plus 2x squared. Down the side, x plus 2. Keep the sign with whatever term it's with. Okay? All right. This works like the old school multiplication table. Remember we had like 1 times 1, 2 times 2, 2 times 1, that thing? It's also an area model from elementary school. I know you learned them because my 9-year-old and I were talking about them the other day. He's like, Mom, I prefer the standard algorithm over the area model. And I'm like, those are really big words for a 9-year-old. So, all right, but it's okay. We're going to do the area model. All right, what's x times 1? X, good. What's x times negative 4x? Negative 4x squared. What's x times 2x squared? 2x cubed. Good. What's 2 times 1? 2. What's 2 times negative 4x? Good. What's 2 times 2x squared? 4x squared. All right. You're going to notice that we're going to do our little combining like terms thing, right? You want to make sure that it's actually the same thing, okay? It isn't always this set of diagonals, but typically across the diagonals we'll see our like terms. Doesn't mean it always happens that way. It could be one is here and one is down here. It just depends on how it was set up to begin with, okay? And sometimes it skips an exponent, all right? So I prefer to go highest exponent first when I'm writing this out. That's how we typically see it. So I'm going to start with 2x cubed, okay? Then I'm going to add together negative 4x squared and positive 4x squared. What happens? They cancel, so I'm not even going to bother write it down. What's x and negative 8x? Good, and then we just write down 2 at the end. The nice thing about the box, you guys, if I don't fill in one of those, I know it's not filled in, right? If I do the rainbow method, look at this. If I try to do this rainbow method, is it really easy to miss one? Yeah, it's super easy to miss one. That's why I prefer the box on this, okay? All right, so you got to make sure your box is big enough that we can actually write stuff in it, okay? All right, so I'm going to do this again. I'm going to do a little bit of it. I'm going to give you a little bit more of it to do on your own this time. All right, so I'm doing my 2 by 3 box because I had a binomial and a trinomial, okay? Trinomial is going to go across the top. So 2x, or 2 plus x minus 7x squared. And then down the side, 3x, and I'm keeping that negative with the 4. Okay? All right, you try to fill out the box this time. See if you can do it on your own. We're only doing example 2, and I'm already having you do it on your own. It must not be that hard, right? I don't think you need it, but if you do, a Desmos calculator is okay. I'm going to give you about 20, 30 seconds on your own. Okay, let's try it. Let's check it together. Okay, so what is 3x times 2? 6x. Good. What's 3x times x? Good. What's 3x times negative 7x squared? 21x cubed. Remember how the other, was it 2 weeks ago? We had to add our exponents when we multiplied. Here it is again, right? We're seeing it in practice. Okay. All right. Negative 4 times 2. Negative 8. Negative 4 times x. Good. And negative 4 times negative 7x squared. 28x squared. All right. Did my diagonals trick work again? Yeah. Remember, it might not be that diagonal. It could go the other direction. Okay. That comes up in the next problem, I think. Okay. So I had people adding things that weren't the same together. All right. And what am I going to put first? Good. Okay. And then 3x squared and 28x squared. 31x squared. All right, 6x and negative 4x. 2x and then minus 8. Easy peasy lemon squeezy? All right, any questions? All right, I want you to practice 2 on your own. So you're going to do 3 and 4 only. Don't do 5 yet. Okay, just 3 and 4. Everybody try 3 and 4.
No, because they're both negative, so when they times. Oh, I was looking at the wrong number equation. Because we times right. Yeah. Exactly.
Again, if you need a calculator, that is okay. Make sure you're trying both 3 and 4. I'm going to give you about 20-30 seconds on your own. I know I made you do 2. See what you can do in 30 seconds. And we're done. Okay, I want you to talk about it with your table. Compare your work, even if you're not all the way done. Okay, it's okay. At least compare number 3.
Did you get negative 4x squared cubed plus 16x squared plus 51x minus
I'll make a bigger one. Did you get another one?
Yeah, I lost the table.
That's not I'm the one. Oh no, you did it. I was trying to make it.
Okay, let's talk about it a little bit. You're going to help me. All right, so I have 4 minus 7x. I did see a few people write their boxes a different way, and that's okay. All right, so what do we get for 3 times 4? What about 3 times negative 7x? Good. What's 3 times 5x squared? 15x squared. All right, what's 2x times 4? 8x. 2x times negative 7x. I don't hear a lot of people. All right, what's 2x times 5x squared? That's a little better, 10x cubed. All right, what about my diagonals? Were they the same diagonals this time? No, we went the other way, and that's okay. It doesn't always have to be the same ones, okay? It doesn't even have to be the diagonals. It's just about 95% of the time it's on the diagonal. All right, what term went first? 10x cubed. What was on for my squareds? What'd I get? X squared, and 8 and negative 21 is? Good, plus 12. If you put them in a different order, I cannot mark that wrong. Okay? It does not have to be the highest to the lowest. That's just how we tend to see it. Okay? So if you put the 12 first, that's fine. Okay? All right, any questions on that one? All right, let's do one more here. Let's check it. So 3 minus 8x minus 4x squared and x minus 6. All right, what's x times 3? X times negative 8x. Good. X times negative 4x squared. Good. Negative 6 times 3. Negative 6 times negative 8x. And then negative 6 times negative 4x squared. 48. Thank you. Ooh, where did that come from? I don't even know. I don't know. What's negative 6 times negative 4? Good. Okay, and then it looks like diagonals went this way. So my final answer, I got negative 4x cubed. What do we get for our squareds? Good. And then for my x's? 51x minus 18. All right. Who is excited to do this next one? Oh, good. I have one. There was one in third period too. Look at how exciting this is. Do you know what happened at lunch when I told the Algebra 2 teachers this is what I was doing to this today? They're like, oh, so you're multiplying a binomial times a binomial? I'm like, no. We're going to multiply a trinomial times a trinomial because we're the advanced class, right? So, guess what? The only difference here is the size of my box, okay? You're going to probably do the whole diagonal, the whole like across 3, okay? I'm going to put this first one up top. It doesn't matter. You pick your favorite way, okay? Guess what? I know half of you aren't listening or already doing it. So I'm not going to do it. I'm going to let you try it before I get in there and do it with you, okay? One last one on your own. I know you can do this. Add up the, remember, combine your like terms coming out of your box, right? You don't have to write all of them. That's why we did the box. Be like 15, 20 more seconds. I still see a few people working on it. Okay, if you're done, take the opportunity to compare with somebody. Okay? Make sure you're the same. Watch your signs. It's really easy to mess up the signs. Okay? It was fun. See? Sometimes it's good to have a chance. I could just put that one on the test, right? Yeah. Just that one. So. It makes you feel good when you can do one that's challenging, right? When I'm done with this one, you can go. Okay? You just literally had lunch. Okay? You're fine. I can hold it, you can hold it for 2 more minutes. All right, let's do it together really fast, okay? So, what is 3x squared times 2x squared?
6x.
Remember, I'm adding those exponents. All right, 3x squared times 5x. Cubed, good. 3x squared times -1. Good. It's -6x times 2x squared. Good. -6x times 5x. Good. -6x times -1. Good. 2 times 2x squared. Good. We're almost done, guys. 2 times 5x. Good. And 2 times -1. Okay. Did my diagonal trick work again? Yeah. Okay. So across the diagonals, I've got 6x to the 4th, -12x cubed, and 15x cubed. What'd you get? 3x cubed. 4x squared minus 30 minus 3. 29x squared, and then 10 plus 6. And then minus 2. Okay? We handle it? All right. There is some practice out there. You've got some time. We are going to do the weekly skills check quiz. I need the last 8 minutes of class. Okay? So, go to classwork. You can use the board markers on the desks. It's a Delta Math. Get some practice in on this right now. Okay? Yeah. It's the one on the white from the whiteboards. Okay? The biggest mistake people are making on it I've seen is the signs. Not watching your signs. Okay, yes, you can go now.